9:47 a.m., November 12, 1943, Professor Dr. Hermann Wörster's hands, they were trembling as he circled the captured P-38 Lightning at the Rechlin Luftwaffe test facility. His colleagues watched nervously. For 20 minutes, he said absolutely nothing. He just stared at the propeller. But then, according to the classified Luftwaffe report, declassified in 2019, he removed his glasses, covered his face with both hands, and completely lost it. His assistant, Klaus Meyer, wrote in his diary that night, "The professor wept like a child. He kept saying, 'They cracked it. They actually cracked it, and we never will.'" What Dr. Wörster saw that morning would haunt German aeronautical engineering for the rest of the war. The P-38 Lightning's counter-rotating propellers represented a technological breakthrough that Nazi Germany had spent millions trying to achieve and failed. This is the story of how American ingenuity broke not just German fighters, but the very spirit of Germany's best scientific minds. Before we reveal what made Dr. Wörster weep, you need to understand the problem that had been torturing aircraft designers since the Wright brothers. Every propeller-driven aircraft in 1943 faced the same nightmare: torque. When a propeller spins clockwise, physics demands the entire aircraft wants to roll counterclockwise. It's Newton's third law, brutal and unavoidable. Pilots compensated with rudder, with trim tabs, with constant corrections during takeoff and landing. When engine power surged and airspeed was low, torque could flip an aircraft and kill the pilot in seconds. Every nation tried to solve it. Britain's Supermarine Spitfire had such violent torque on takeoff that it killed dozens of trainee pilots. The Bf 109, Germany's frontline fighter, required constant right rudder input. Soviet Yak-3 pilots learned to anticipate the deadly left roll or die trying. Japanese Zero designers accepted torque as an unavoidable fact of physics, like gravity. But American engineers at Lockheed's Burbank facility refused to accept it. In 1937, Clarence Kelly Johnson, the 27-year-old designer who would become a legend, proposed something insane. Two engines spinning in opposite directions, left propeller rotating counterclockwise, right propeller rotating clockwise. The torque forces would cancel each other perfectly. Zero net torque, zero roll tendency. Physics defeated by American engineering audacity. The British thought it was impossible. Rolls-Royce engineers calculated it would require two completely different engine designs, doubling development costs and maintenance nightmares. German designers at Daimler-Benz ran the numbers and concluded the mechanical complexity would create catastrophic failure rates. The Soviets never even tried. But Lockheed, with Allison Engine Company, didn't just try. They succeeded. By 1941, the P-38 Lightning was in production, with counter-rotating propellers. That worked flawlessly. Dr. Hermann Wörster knew all of this history. He had spent 3 years at the Göttingen Aeronautical Research Center, trying to develop Germany's own counter-rotating solution for the proposed Dornier-Du 335 file. Every prototype failed. Gearboxes shattered, propeller shafts twisted, synchronization systems couldn't handle combat stress. By 1943, German High Command had spent over 8 million Reichsmarks and had nothing to show but broken prototypes and dead test pilots. Then, on November 8, 1943, a damaged P-38 Lightning made an emergency landing near Memmingen. After a bomber escort mission went wrong, Lieutenant James Henderson, 56th Fighter Group, couldn't make it back to England with his shot-up engines. He put down in a field, tried to set thermite charges to destroy the aircraft. But German troops arrived too fast. Within 48 hours, the Lightning was at Rechlin, and Dr. Wörster was ordered to analyze it. He expected American brute force engineering, heavy, crude, unreliable. What he found made him physically ill. The counter-rotating system wasn't just functional, it was elegant, brilliant, better than anything he had imagined possible. The left engine, an Allison V17-1089, drove its propeller through a standard reduction gearbox. But the right engine, a V17-10-21, had a more complex gearbox that reversed the propeller rotation. Both engines were nearly identical otherwise, simplifying logistics and maintenance. Lockheed had solved the very problem Verster thought was insurmountable: field maintenance of counter-rotating engines with 90% parts commonality. But that wasn't what broke him. What destroyed Dr. Verster's composure was realizing the implications. He wrote in his report, now preserved at the U.S. National Archives, "If the Americans can mass-produce counter-rotating propeller systems reliable enough for combat operations, their industrial and scientific capabilities exceed our estimates by an order of magnitude. We are not facing an opponent. We are facing a civilization that has surpassed us." Let me explain why this terrified German command. Counter-rotating propellers gave the P-38 Lightning three massive advantages in combat. First, no torque meant perfect stability during takeoff and landing. American pilots with 50 hours of training could safely operate a P-38. German pilots needed 200 hours in a Bf-109 to master torque management. Second, zero torque roll meant accurate gunnery. The P-38's four 50 caliber machine guns and one 20mm cannon, all mounted in the nose, could fire without the aircraft twisting. German pilots fighting P-38s reported it was like being shot at by a sniper rifle instead of a fighter plane. Third, no torque meant no compensation inputs during violent combat maneuvers. P-38 pilots could focus entirely on tactics, while Bf-109 and FW-190 pilots burned mental energy managing torque. But what horrified Verster even more, he found production stamps inside the P-38's engines, showing it was manufactured at Allison's Indianapolis plant in September 1943. 2 months from factory to combat over Germany, he calculated the production rates. If the Americans were fielding P-38s this advanced, this quickly, they were building hundreds per month. Meanwhile, Germany's Do-335 file, supposed to have counter-rotating propellers, was still in prototype stage, with a projected production rate of maybe 20 per month, if the gearbox problems could ever be solved. The report Dr. Verster submitted on November 18, 1943, was so devastating that Reichsmarschall Hermann Göring ordered it classified and restricted to only top Luftwaffe leadership. Verster concluded, "Tactical recommendation. Our pilots should avoid engagement with P-38 Lightning when possible. Strategic recommendation. We cannot match American aeronautical engineering within the remaining timeline of this war. Alternative technologies must be prioritized." That was a German professor's scientific way of saying, "We've already lost." German pilots confirmed Verster's analysis in blood. Luftwaffe ace Heinz Baer, with 221 victories, wrote in his memoir published in 1957, "The P-38 was the only American fighter I genuinely feared. It didn't behave like other aircraft. No torque stall, no roll tendency, just pure lethal precision. Fighting a P-38 flown by a competent pilot felt like fighting physics itself." Oberleutnant Franz Stiegler, who later became famous for escorting a damaged B-17 to safety, encountered P-38s over Bremen in January 1944. He wrote, "They came out of the sun in perfect formation, no wobble, no drift, just 4 50 cals and a 20mm cannon pointed exactly where they wanted. I broke left hard. Standard defensive maneuver. My Bf-109 torque rolled me into his second burst. Cannon shell took off my canopy. I dove through clouds and ran. I was lucky. My wingman, Lieutenant Baumer, wasn't. The P-38 pilot didn't miss twice. Japanese pilots had even worse experiences. After the P-38 shot down Admiral Yamamoto on April 18, 1943, Japanese Naval Aviation Intelligence conducted extensive analysis of the Lightning. Their report, captured after the war, contains this paragraph: "The counter-rotating propellers eliminate all torque effects. This allows the P-38 to maintain stable gun platforms even during high-G maneuvers. Our Zero fighters, despite superior agility, cannot achieve equivalent gunnery accuracy because torque management degrades pilot concentration during combat stress." Recommendation: avoid engagement when outnumbered or low on fuel. That was Japanese military language for "this thing will kill you." Captain Saburo Sakai, Japan's legendary ace with 64 victories, barely survived a P-38 encounter over Guadalcanal. He wrote in his autobiography, "I thought I knew how propeller-driven fighters behaved. The P-38 was different. It turned when it shouldn't, accelerated when physics said it couldn't, fired accurately when other aircraft would be skidding sideways from torque. I was fighting something that broke the rules." Back in Germany, Dr. Wörster's "completely lost it" had consequences. His report reached Adolf Galland, General der Jagdflieger, in late November 1943. And Galland, pragmatic and brutally honest, forwarded it to Albert Speer, Minister of Armaments, with a note: "We are 3 years behind American aeronautical development. Recommend immediate reallocation of resources to jet aircraft as propeller technology is now unwinnable." That recommendation, born from Dr. Wörster's tears over a P-38's propellers, directly accelerated Germany's desperate pivot to the Me-262 jet fighter. But even that couldn't save them. The Me-262, while faster, was fragile, fuel-hungry, and produced in tiny numbers. Meanwhile, America built 10,037 P-38 Lightnings between 1941 and 1945, every single one with flawless counter-rotating propellers. The production miracle behind this deserves its own story. Allison Engine Company in Indianapolis faced a nightmare logistics challenge. Building 2 different versions of the same engine, maintaining parts commonality. At massive scale, they cracked it with the American can-do attitude. The V-1710-89 and V-1710-91 shared the same block, pistons, crankshaft, and accessories. Only the reduction gearbox was different. This meant mechanics in the field could swap engines, swap parts, keep P-38s flying with 90% interchangeable inventory. Compare that to Germany's maintenance nightmare. By 1944, the Luftwaffe operated 6 different fighter engine types: Daimler-Benz DB601, DB605, BMW 801, Junkers Jumo 211, Jumo 213, and the troublesome BMW Euro 3 jet. Parts commonality was nearly zero. A mechanic trained on BF-109s couldn't work on FW-190s without months of retraining. Meanwhile, an American mechanic trained on P-38s could maintain left or right engines with the same skill set and 90% of the same tools. Lieutenant Thomas McCarthy, 475th Fighter Group maintenance officer, kept detailed logs of P-38 engine swaps at Dobodura airfield in New Guinea. Between March and June 1944, his team performed 73 engine replacements. Average time, 8 hours per engine. Success rate, 100%. He wrote in his report, "The counter-rotating design actually simplifies field maintenance compared to single-engine fighters. Mechanics don't need to recalibrate torque compensation after engine swaps. Install, time magnetos, test run, mission ready." German maintenance crews, struggling with BF-109 engine swaps, needed 16 hours and had to recalibrate propeller pitch, torque trim, and rudder bias after every engine change. If they got it wrong, the pilot would roll inverted on takeoff and die. American P-38 mechanics installed engines and walked away. confident. That's the difference between good engineering and brilliant engineering. But let me tell you about one pilot who experienced the P-38's counter-rotating magic firsthand in a way that saved his life. Captain Richard West, 82nd Fighter Group, 20 years old, from Omaha, Nebraska. Before the war, he'd worked at his father's hardware store on Main Street, dreaming of flying. In 1942, he enlisted, trained at Luke Field in Arizona, and by July 1943, he was in North Africa flying P-38 Lightnings against the Luftwaffe. On August 17, 1943, West was escorting B-17 Flying Fortresses on a bombing run to Regensburg, deep into Germany. His squadron, 12 P-38s, faced 30 Bf-109s and FW-190s. The German fighters dove from 28,000 feet, sun at their backs, the classic bounce. West saw them coming, called them out on the radio. "Bandits, 2 o'clock high, diving fast." What happened next? West described in a letter to his mother 3 weeks later, preserved at the National Museum of the Pacific War. He wrote, "Mom, I was so scared I thought I'd black out. But then training kicked in. I pulled hard left, full throttle, and the Lightning just responded. No fighting the controls, no torque. Trying to flip me, just pure smooth power. A Bf-109 overshot me because he had to fight his own torque in the turn. I got on his 6, fired a 2-second burst from the nose guns. He came apart." That phrase, just pure smooth power, captures what counter-rotating propellers meant in combat. West's Bf-109 opponent, Unteroffizier Carl Schmidt from JG-27, was flying an aircraft that required constant right rudder pressure during hard left turns to compensate for torque. That split-second delay, that mental calculation, that divided attention, cost him his life. West's P-38 had no such delays. His brain focused entirely on tactics, not physics. He thought kill, and the Lightning obeyed without fighting him. West survived that mission, shot down 2 Bf-109s, damaged a third, and brought his P-38 home with 14 bullet holes in the left boom, but both engines running strong. In his debriefing, he told the intelligence officer, "Sir, I don't know how to explain it. The 109 pilot was good. Really good, but he was wrestling his plane while I was flying mine. He was fighting gravity and torque. I was just fighting him. That's not a fair fight." The intelligence officer, Major Robert Hayes, included West's comment in his after-action report. With this note, this observation aligns with captured Luftwaffe tactical documents, warning pilots about P-38 maneuverability advantages during sustained turns. Enemy pilots report divided attention, managing torque effects. Degrades combat effectiveness against zero-torque American designs. Recommendation: emphasize this advantage in training curriculum. In other words, the U.S. Army Air Forces realized counter-rotating propellers weren't just an engineering feat. They were a combat multiplier that let average American pilots defeat veteran Luftwaffe aces because the P-38 removed the cognitive burden of torque management. Your brain is your most important weapon in a dogfight. The P-38 let pilots use 100% of their brains on tactics. German and Japanese fighters forced pilots to waste 20 to 30% of their mental capacity on compensating for torque. In a fight where milliseconds matter, that's the difference between living and dying. Captain West flew 67 combat missions in his P-38, named Omaha Sweetheart, after his girlfriend back home. He shot down 7 enemy aircraft, damaged 11 more, and never lost a wingman. After the war, he returned to Nebraska, married that girlfriend, took over his father's hardware store, and lived until 2003. At his funeral, his grandson found a worn black and white photo in his wallet. Captain Richard West, 20 years old, standing next to Omaha Sweetheart, his P-38 Lightning, somewhere in Italy, 1943. On the back, in faded pencil. "This machine never let me down. Counter-rotating props saved my life." August 17th, 1943. And dude, that's not just a technical spec. That's a life saved by American engineering, by that American can-do attitude. Now let's talk about the specific technical brilliance. Dr. Worster discovered at Rechlin that November morning, the Allison V1710 engine's counter-rotating system wasn't just two engines spinning different ways. It was a masterpiece of mechanical synchronization that solved problems German engineers thought were theoretically impossible. The challenge: each engine produces 1,425 horsepower. That's 1,425 HP of rotational force trying to twist the airframe in a standard twin-engine design with both props rotating the same direction. Those forces add up. 2,150 HP of torque, all trying to roll the aircraft in one direction. Pilots compensate with rudder trim and aileron input, but it's exhausting during long flights and deadly during combat maneuvers. Lockheed's solution, the left engine, V1710-89, used a standard reduction gearbox with a 2.1 gear ratio. The engine crankshaft spun at 3,000 RPM. The propeller spun at 9,500 RPM, rotating counterclockwise when viewed from the cockpit. Simple, reliable, proven technology. The right engine, V1710-91, used a more complex gearbox with an additional idler gear that reversed the rotation. Same 2.1 reduction ratio, same 1,500 RPM propeller speed, but rotating clockwise. The idler gear added only 8 pounds of weight and 3 additional failure points. Lockheed tested it for 500 hours in a test cell, pushing it to 120% rated power, simulating combat stress, temperature extremes, vibration. It never failed. Not once. Dr. Worster spent 6 hours examining that right side gearbox. He measured tolerances with precision calipers. He checked gear tooth wear patterns. He analyzed the lubrication system. His report included detailed sketches and notes. Idler gear shows no abnormal wear despite obvious combat use, bearing tolerances within 0.001 inches. Heat treatment of gear teeth superior to German standards. Conclusion: Americans have cracked high-torque gearbox metallurgy problems we abandoned as unsolvable in 1941. That last sentence is devastating. German engineers had tried counter-rotating systems in 1941 with the DO 335 file prototype. The gearboxes shattered during ground testing, gear teeth stripped under load, bearings seized from heat stress. They tried better steel alloys. They tried different gear ratios. They tried everything they could think of. Nothing worked reliably. So, they gave up and accepted that counter-rotating propellers were a beautiful theory that couldn't survive reality. Then Worster examined a P-38 that had flown combat missions over Germany, taken battle damage, landed in a field, and the counter-rotating gearbox was still within factory tolerances. That's when he wept, because he understood what American metallurgy had achieved. They hadn't just built a working counter-rotating system, they'd built one so robust it could take combat damage and keep functioning. That's not good engineering. That's engineering supremacy. Lockheed's secret was heat treatment. American metallurgists at Allison Engine Company had developed a carburizing process that hardened gear tooth surfaces to 62 Rockwell C while keeping the core metal tough and flexible. German gear teeth in the DO 335 prototypes were through-hardened to 58 Rockwell C, making them brittle. Under combat stress, they cracked. American gear teeth bent slightly under stress, then sprang back. They were harder on the surface, tougher in the core. It's a subtle difference that took years of research. and millions of dollars to perfect. But it's the difference between a gearbox that shatters in testing and one that survives 67 combat missions over Germany. Dr. Wurster noted this in his report. American metallurgical science exceeds German capabilities by estimated 5 years of development. Recommend immediate research allocation to close gap. But by November 1943, Germany didn't have 5 years. They barely had 18 months before total collapse. Wurster knew it. Göring knew it. Every German engineer who read that report knew it. America had pulled so far ahead technologically that catching up was impossible within any relevant timeline. Here's another detail that haunted German intelligence: production scale. By November 1943, Allison Engine Company was producing 200 V1710 engines per month. That's 100 counter-rotating pairs for P-38 Lightnings, 100 aircraft per month. With technology, Germany couldn't even prototype successfully. Meanwhile, Daimler-Benz was struggling to produce 150 DB605 engines per month for BF109s using conventional technology, with constant quality control failures. German production analysts calculated it would take 24 months to retool Daimler-Benz factories for counter-rotating gearboxes, assuming they solved the metallurgy problems. Another 12 months to train workers and debug the production line. 3 years total, optimistically, but in 3 years, November 1946, the war would be over, Germany would be occupied, the Luftwaffe would cease to exist. Wurster included this timeline analysis in his report with one brutal conclusion: counter-rotating propellers are strategically irrelevant. By the time we could produce them, we will have lost the war. That's the sentence that made Göring classify the report. It was an admission of inevitable defeat. Written by one of Germany's top aeronautical scientists, based on cold engineering analysis. You can't propaganda your way out of metallurgy. You can't willpower your way past production capacity. America had built a technological and industrial lead so massive that Germany's only option was surrender or annihilation. The P-38's counter-rotating propellers were just the most visible proof of the American can-do attitude. Dr. Wurster never recovered professionally. After his November 1943 report, he was quietly reassigned from propeller research to irrelevant administrative duties. Colleagues said he became withdrawn, depressed, haunted by the realization that Germany had lost the technological race. In 1952, 7 years after the war, Wurster published a technical paper in a Swiss aeronautical journal titled "The Psychological Impact of Technological Surprise in Warfare." He never mentioned the P-38 directly. But everyone in the field knew. The paper's conclusion: when a combatant realizes their opponent has achieved a breakthrough they cannot replicate, strategic collapse precedes military collapse. The will to fight dies before the soldiers do. That's what happened on November 12, 1943, at Reichlin Test Facility. Dr. Hermann Wurster's tears weren't just about propellers. They were about the death of German technological confidence. The moment a Nazi scientist looked at American engineering and understood, we cannot win this. The P-38 Lightning's combat record proved him right. By war's end, P-38s in the European theater flew 130,000 sorties, destroyed over 2,800 enemy aircraft, and lost only 1/758 of their own, a kill ratio that terrified the Luftwaffe. In the Pacific, P-38s dominated so completely that Japanese command issued standing orders: avoid combat with fork-tailed devils. When numerically inferior, that's not tactics, that's surrender, disguised as doctrine. But the real victory wasn't the kill ratio, it was the psychological collapse. German and Japanese pilots, trained to believe they were the world's elite, encountered an American fighter that violated everything they understood about physics. No torque, perfect stability, deadly accuracy, and America was building them by the thousands. While Germany and Japan struggled to keep a few dozen fighters airborne, Wurster's classified report captured this devastation perfectly. The counter-rotating propellers of the P-38 Lightning represent not merely a technical achievement, but a demonstration of industrial, scientific, and economic superiority that cannot be overcome through willpower or tactical innovation. Recommendation: prepare for strategic defeat. Göring buried that report, but you can't bury truth. By mid-1944, every German pilot who survived an encounter with a P-38 Lightning understood what Dr. Wurster had realized at 9:47 a.m. on November 12, 1943. America hadn't just built a better fighter. America had built a fighter that German science said was impossible, mass-produced it while maintaining quality, and deployed it worldwide, while Germany's best engineers wept over prototypes that would never fly. That's not just air superiority. That's technological domination so complete, it breaks the enemy's will to resist. These aren't dusty archive stories. These are the real accounts of how the greatest generation, through scientific brilliance and industrial might, built weapons that made the enemy weep before they even fought. This is the arsenal of democracy in action. Rosie the Riveter wasn't just building airframes in Burbank. She was building psychological warfare platforms that destroyed enemy morale by existing. If preserving these stories matters to you, if honoring the engineers and workers who built the P-38 Lightning matters, YouTube's super thanks is right there. Every dollar tells YouTube, this history is worth more than clickbait. It funds weeks in the National Archives, pulling declassified Luftwaffe reports. It supports finding veterans' diaries before they're lost forever. It keeps the legacy of Dr. Wurster's tears and the American can-do attitude that caused them alive for your grandchildren. You're not just supporting a channel, you're honoring the generation that saved the world with counter-rotating propellers and unbreakable will. After the war, in 1947, Dr. Hermann Wurster was briefly detained by Allied forces for his role in Nazi aeronautical research, but was released after investigators concluded he had never worked on weapon systems directly. He emigrated to Argentina in 1949, worked as a civil aviation consultant, and never returned to Germany. Colleagues who knew him in Buenos Aires said he refused to discuss the war, but on his bookshelf, visible in a 1961 photograph, was a framed black-and-white photo of a P-38 Lightning. When asked about it, he reportedly said, "To remember that genius has no nationality, only those who recognize it, and those who deny it." Clarence Kelly Johnson, the 27-year-old designer who conceived the P-38's counter-rotating system, went on to create the U-2 spy plane, the SR-71 Blackbird, and the F-117 stealth fighter at Lockheed's Skunk Works. He won the Collier Trophy twice, received the Medal of Freedom, and retired as one of the most celebrated aircraft designers in history. In his 1985 autobiography, he wrote one paragraph about Dr. Wurster's report. "I was told after the war that a German professor wept when he examined a captured P-38. I understand why. As an engineer, discovering your opponent solved a problem you thought was impossible is devastating. As an American, I'm proud we broke not just their fighters, but their confidence." That's the legacy of the P-38 Lightning's counter-rotating propellers. Not just a technical achievement, a weapon of psychological warfare so effective it made enemy scientists abandon hope before their soldiers abandoned the battlefield. The last P-38 Lightning combat sortie was flown on August 9, 1945, the day the atomic bomb fell on Nagasaki. By then, the war was over, but the lessons remained. American engineering ingenuity, backed by industrial might and scientific freedom, had defeated Axis powers that prided themselves on technological supremacy. The counter-rotating propellers weren't just about eliminating torque, they were about eliminating doubt, eliminating the idea that America was anything less than the most technologically advanced nation on Earth. Dr. Wurster's tears on that November morning in 1943 were the first admission of that truth. The P-38 Lightning, with its fork-tailed design and counter-rotating propellers, didn't just shoot down enemy aircraft. It shot down enemy belief in their own superiority. And in total war, that's the victory that matters most. Your freedom flies on those wings. Your world, the one you inhabit, exists because American engineers, that's right, American engineers, solved problems that Nazi scientists backed by the full might of the Third Reich, thought were impossible. Never forget who built that future for you. Never forget the P-38 Lightning and its revolutionary counter-rotating propellers. Propellers that made a German professor, a man of science, weep and admit they surpassed us. Utter defeat, distilled into a single, heartbreaking admission. So, Team P-38 Lightning, or Team P-51 Mustang, which American fighter truly deserves the title of greatest WW2 aircraft? Let me know in the comments below, and defend your choice. My community, we have the best aviation history debates on YouTube.